Just all look up, all right? All look up, no need to look at notes, no need to copy actually. We have population, correct? And the population can be height, can be weight, can be number of children in the family, number of people in the family, etc., etc. The entire population means you, whatever that you're interested in, it could be the entire Singapore, it could be the entire school, etc., etc. You have plenty of data. And surely there must be a expected value of x. That means long-term average value of x. That means you take enough data and then long-term average value of x. Take 1, take 2, take 3, take 3, 4, 5, 6, 7, 8, 9, blah, 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 blah. Everybody, divide by n, you will get expected value of x. Let it be mu. This is just a symbol. Thank you. Settle down, thank you. Come. There is also a variance of x. Okay, I don't know whether you remember how to calculate, but never mind. That's the spread of the data. Now this one we talk about x. Now what we learned on Tuesday was this. Thank you. If I pick, say 3, x1, x2, x3, that means pick 3 data and then divide by 3. This variable called x1 plus x2 plus x3 over 3 is what we call x bar. Now we have also learned, thank you, settle down, thank you, that the expected value of x bar and the variance of x bar are related to the expected value of x and variance of x. We learned that expected value of x bar is actually mu. We have learned that variance of x bar is sigma square over 3, or in general case, if this is n, then it will be n, depending on how many you take at one point. Follow so far? Okay? And we went on to say that, now this applies for anything. Have attention please. This applies for all distribution. Throughout here, I didn't say anything about the distribution of x. That means x can be normal, Poisson, binomial, etc. This will always be true. This, I want to say this, this is true for all distributions of x. Always true. However, what we have done on Tuesday was, if x is a normal distribution, x bar must be normal distributed. Also follow a normal distribution. So that's how we can do calculation. Because if it's not normal, we also don't know how to do. Follow what I'm saying? So that's what we have done now. Alright? So let's carry on with example 2. Example 2. Okay, again we say, okay, now the question says that cylindrical rods, radii normally distributed with mean 0.5, standard deviation 0.005. Now then this one is quite easily. This is just translating this to a mathematical statement. Now 2 of the rods are selected at random. Find the probability that the sum of the 2 they are radii. Now, sum of 2 radii. We let S be equals to R1 plus R2. Correct? You actually take 2 rods. And these 2 rods are picked at random, means that these 2 rods are independent observations of R. So far so good. Okay? Next. Therefore, using this idea, because you add 2 normal distribution up, actually there is this one you don't need me to tell you. The mean should just be the mean of R1 plus mean of R2 which is 2 times 0.5. What will be the variance? The variance is not 2 square, it's just 2 times 0.005 square. Any problems with that? Because we have two independent observations of R, we just treat this as x plus y. So therefore, this is 0.005 plus 0.005, or rather 0.005 square plus 0.005 square. Any problems? So, that means, there's one more line here. S follow a normal distribution, mean 1 and 0.00405. Okay? With that, we key in the GC, no problems, we get our answer. We get something like that. No problem, this is quite easy. Alright? In part 2 asks, find the probability that the diameter of a randomly chosen rock is less than 0.994. So now we talk about diameter of one randomly chosen rock. It's not R1 plus R2 anymore, because you are actually picking one rock. You only pick one type. Correct? So, since D is the diameter, D is now 2R. Because you only pick one. There's only one rock that we're talking about. 2R. Make the distinction. Okay, later I'm going to be very deliberate in explaining this, but now in your mind you should also have some idea. Correct? 2R. Now, this is also a normal distribution problem. You could easily do it for, if I set this for a CT2 problem, you also can do it. Correct? 2R. Expected value of D must be 2 times of expected value of R. Variance. Now, let's be very clear. This must be 2 square variance R, which is now 4 times 0.005 square, which is now 0.001. Hey, how many zeros? 3 zeros, sorry. Got it? This is important, yeah? There must be a square. Why must there be a square? Because D is 2R. Correct? Now realize then that D follows this normal distribution with mean and variance. You press your calculator, you realize that this value is 0.274. Now let's look. Look at this value and look at this value. Clearly they're different. Why are they different? Because R1 plus R2 is different from 2R. Or rather, R1 plus R2, the distribution of R1 plus R2 is different from the distribution of 2R. They are different also because of the variance. Follow? Okay, the variance are different. So how do you distinguish in general? Now, if you have, wait, now I think I can pause this one.